Hello, good morning everyone to MSA Physics first year students, Department of Physics. I am BV Vamsi Krishna, Assistant Professor, Department of Physics, AKNU Rajahmundry. So today I am going to discuss about silicon control rectifier. So, what is this silicon control rectifier? So it consists of two p-type semiconductors and two n-type semiconductors. These are joined alternately. Means p-type is first the p-type is connected to the n-type, then n-type is connected to the p-type semiconductor. P-type semiconductor is connected to the n-type semiconductor. So there is a one gate terminal is connected to this p-type semiconductor. So you know that in P type the majority carriers are holes. In N type the majority carriers are electrons. So when we joined these say two type of semiconductors, P type and N type, when we join P type and N type semiconductors, the electron will flow from N type semiconductor to the P type semiconductor. Okay, so after equilibrium attains, what will happen? There will be a depletion layer formed. That depletion layer we call it as junction. So, okay, so when we join the four semiconductors, means P4 PN, then the three junctions will be formed. Okay, so when we joined any two semiconductors, first we join PN, then J1 will form, junction J1 will form. Then we joined N and P. Then then J2 junction is formed. Then PN, then we joined PN semiconductors. J3 junction is formed. Okay, so this is the uh, representation of silicon control rectifier. Okay, there is a gate control over the p type semiconductor. It is given to the p type semiconductor. So SCR is a four layer 3 terminals PN semiconductor device. It has three junctions, namely J1, J2, J3. Since it conducts current only in one direction, as like diode, the silicon control rectifier is also conduct current in only one direction. It is also known as a unidirectional device. So why we name the why how the name the control rectifier came, ఎలా వచ్చింది కంట్రోల్ రెక్టిఫైర్ అనేది ఎలా వచ్చింది? బికాస్ ఆఫ్ ద గేట్ టెర్మినల్ ఈజ్ గివెన్ టు ద p type semiconductor. It is control rectifier because this device requires a gate signal to turn it on. Means to turn the to make SCR to be functional. To make SCR to be functional, so we have to give a gate terminal, means gate signal to the SCR device, so it will turn it on, means it will turn on. Okay, so SCR operations are classified in the four modes. One is forward blocking mode, second one is forward conducting mode, third one is reverse blocking mode, and fourth one is reverse conducting mode. So I repeat, SCR operations is classified into the four modes. Okay, the first consider the forward blocking mode. So in forward blocking mode, this positive terminal of external battery, means external source of positive terminal of the battery is connected to the p type, and negative terminal is connected to the n type. Then it is in the forward bias condition. Okay, so when so we call it as a anode. This is a cathode because the positive terminal is connected to the p type, then we call it as anode. Negative terminal is connected to the anode. Okay, so with respect to, so J1 and J3 are in the forward bias conditions, why, but J2 is in the reverse bias condition because of this external battery. So మీకు తెలుసు కదా, you know that so when positive terminal is connected to the p type and negative terminal is connected to the n type, then this configuration is called as a this configuration is in the forward bias condition, means configuration. So understand, are you catching? So uh, when when positive voltage is connected to the p type and negative terminal is connected to the n type, then we call it as a forward bias condition. So with respect to that, this, so if you see that this positive terminal is connected to the n type semiconductor, and negative terminal is connected to the p type semiconductor, so the J2 is in the reverse biased condition, but J1 and J3 are in the forward biased condition, means junctions J1 and J2 are in the forward biased condition. When anode voltage is made positive with respect to the cathode, then SCR is said to be forward biased, as J1 and J3 are in forward biased, and J2 are in reverse biased. Okay, so as the junction J2 is reverse biased, so what will happen? So you know that when we, so you know that let us consider a simple PN junction diode is in the reverse bias condition. So what will happen, the when we connected the battery in the reverse bias condition with respect to the PN junction diode, so there will be a small amount of current will flow from N type to the P type region. Okay, that current will be in the few milliamperes, as like here, uh, as PN, as the junction J2 is in reverse bias condition, only small amount of only small leakage current of several milliampere flow through anode to cathode. So has no anode current IA flow in the circuit, the device is said to be off state, and the leakage current which flow through the SCR is called off state current. So forward conducting mode, let us talk about forward conducting mode. So again, this forward conducting mode is classified into the two types, without gate current and with gate current. So let us know about in detail without gate current, conduction without gate current. So without gate current is so when we connected here also, the positive terminal is connected to the p type, the negative terminal is connected to the n type. So three junctions will be formed, J1, J2, J3, as you know that. So IA is the anode current which is passing from the positive terminal of the battery to the p type region, with anode voltage made positive with respect to the cathode. If anode VAK is increased, VAK is the potential difference between these J1 and J2, okay, is increased to the sufficient high value, means Vk is the also a potential difference of the battery. Okay, when we increase the voltage to the sufficient high value, reverse bias junction breakdown due to the avalanche breakdown. So when we increase the voltage to the sufficient high value, the reverse biased junction, that is J2, will break down. That is called that due to the avalanche breakdown. The voltage at which this avalanche breakdown occurs is called forward breakover voltage. That is name it as VBO. The junction J1 and J3 are already forward biased, and breakdown of so what happened was here. So due to when we increase this voltage V to the sufficient high value, the reverse biased junction J2 will break down due to the avalanche breakdown. So there will be no junction of J2. So there will be easy flow of electrons from the this p-type region to the n-type region, means anode to the cathode. Okay, from J1 to J2 there is a free flow of electrons, because there is no junction at of J2. There is no junction J2 because of the avalanche breakdown. The junction J1 and J3 are already forward biased, and breakdown of J2 results in the free movement of carriers across all three junctions, result in the large forward anode current IA can be limited by the external resistance. As SCR conducts the voltage across the device, the fall to the small value between 1 to the 1.5 volts, which is a voltage drop across the resistance offered by all the four layers of SCR. So why this voltage across these four layers is dropping from 1 to 1.5 volts? When junction is in forward bias condition, it offers very low resistance. But junction J2 is in the reverse bias condition, it got avalanche breakdown. So there is a free flow of electrons to the junction, hence it is offering no resistance at junction J2. So as I discussed earlier, the junction is in the forward bias condition. Okay, so we are operating the SCR in the forward bias condition, so it offers very low resistance because the junction will be very narrow. Okay, when the PN junction diode is in the forward bias, the depletion layer will be very less, so there is a flow of electrons from the n-type region to the p-type region. Okay, so so it offers the very low resistance. But junction J2 is in the reverse bias condition, it got but it is in the reverse bias condition, but it got avalanche breakdown. So there is no junction is disappeared here junction is disappeared. So there is a free flow of electrons from the junction through the junction, hence it is offering no resistance at junction J2. Understood? So why the voltage across these four layers is dropping the 1 to 1.5 volts? Because of this avalanche breakdown. There is no resistance at the junction J2. When it is in the forward bias, the junction J1 and J2 are offers the very less resistance. So there is a easy flow of electrons. Understood? Okay. So now discuss about conduction with gate current. So so now we are dealing with gate current. So with gate current, so we apply some voltage. We apply some external voltage to the p-type semiconductor, and the negative terminal is connected to the anode. So without breakdown of the junction J2, and before the breakdown without breakdown of junction J2, SCR can be made on by applying the positive voltage to gate with respect to the cathode. So positive terminal of the battery is connected to the p-type, and negative terminal is connected to the cathode. Thus, due to the gate potential, there is a, so due to the gate potential, so what happened, so we have connected the positive terminal to the p type region, and negative terminal is connected to the cathode. So here here the, here the positive terminal is connected to the p type region. So electrons will flow from electrons will diffuse from the n type region to the p type region. Okay, has like the holes also diffuse from the p type region to the n type region across the junction J3. So injection of electrons in the p type region will act as a majority charge carriers. So why, so because of the forward bias condition, so this gate is also in the forward bias condition, this external voltage is also in the forward bias condition. So what happens, the from p is in the middle, so electrons will flow from n type region from both sides. So there will be more injection of electrons into the p type region. So now the electrons will be a majority carriers in the p type region. Injection of electrons in the p type region, the force this region to lose its identity as p type. Therefore junction J2 has electrons has majority carriers on its both sides. I already said that from the bottom of n type region, the electron will flow to the p type region. Electrons in the on the top region, n type of the top region of n type semiconductor will diffuse electrons into the p type region. So in the p type, the electrons will be the majority charge carriers. Okay. So due to that J2 junction J2 will be disappeared. The device start conducting from the J1 to J3 as already in the forward biased. The forward biased at which the device starts conducting the depends on the gate current. So the more gate current, the less will be the forward voltage to turn on the SCR. So the current in the conducting mode of SCR IK is equal to IA plus IG, where IA is the anode current, so IK is the cathode current, IG is the gate current. So how we wrote this expression is based on the current flow. So anode is entering into the p type region, gate current is also entering into the p type region. So sum of these two currents will be the equal to the cathode current. That's what we have written here. So the third one is reverse blocking mode. Here the negative terminal is connected to the p type region and positive terminal is connected to the n type region. So at the junctions, so at top layer there will be electron electron electrons are in the majority carriers. In bottom layer of in top layer of n type region, holes are the majority carriers. When cathode voltage is positive with respect to the anode, the cathode voltage is positive with respect to the anode, the junction J2 is in the forward bias, whereas J2 and J3 are in the reverse bias condition. So it is quite opposite to the forward bias blocking mode. Okay, so as like so as like a uh, sorry, uh, here J means negative terminal is connected to the anode, the positive terminal is connected to the cathode, so that so J1 and J2 act as a for reverse bias condition, and the J2 is act as a forward bias condition. Due to the two reverse bias junctions, only the reverse leakage current known as current flow in the device. The device is said to be in reverse blocking state. The only minority charge carriers will flow. So reverse. So now let us discuss the last one, reverse conducting mode. Now if the reverse voltage is increased to the sufficient large enough, The breakdown of junctions J1 and J2 take place because of the avalanche breakdown, as we discussed in the forward conducting mode, and the device will conduct. So this avalanche breakdown of the junction could be destructive, and hence device is not used in this mode of operation. Okay, so I hope you understand this silicon control rectifier. Okay, thank you.